Hey there, let's talk about permutations and combinations. So here we have our imaginary menu, and we have apples, bananas, cherries, and dills. What we need to find out is how many can we take out, how many unique ways can we take out 2 of the 4 apples. Fruits, I guess, what a dill is. Yeah, anyways, so we would take, let's say, 2 out of 4. What we need to know is the different ways. So we would use permutations or combinations. And what they are kind of formulas, methods to take away out different methods, ways to, A lot of times you'll get a problem and it'll specify you if order does matter or does not matter. And it does matter for permutations, but it does not matter for combinations. What this means is that, let's say we take out apples and bananas. So I ordered apples and bananas. What it means is that in combinations, it wouldn't matter if we said, oh, let's order bananas and apples. Well, you know that it doesn't matter what the order is, they're still the same thing. You still got apples and bananas. In some situations, it does matter. Let's say you're trying to be first place. You don't want to be, let's say, you're first place and your friend's in second place. It would be a lot different if you were second place and your friend was first place. So in those cases, permutations is what we would use. Here we would use combinations because it doesn't really matter. Let's say we ordered cherries and dills, or we ordered bananas and cherries, or apples and bananas. So there's actually 4 different ways we could order. 6 different ways, because we could order apples and bananas, apples and cherries, apples and dills, and bananas and cherries and dills. So let's get on with another example. So these are the 2 formulas for permutations and combinations. Permutations, we would have the same thing as combinations except for this extra r, which let's call it remainder. So let's say n, we have 4 fruits again. So we have 4 fruits and we need to choose 2 of them. And n would be 4, so we could write 4 factorial over 4 minus r would be 2 factorial, which ends up to be 4 factorial over 2 factorial. And if you don't know what a factorial is, it's basically every number underneath the number that has the exclamation mark. So 4 times 3 times 2 times 1, which is 24. So this would be 24 over 2, which is 12. In the problem we just did, that was a combination, which means we would use the second formula, and that would be the same thing, except we add another 2, so that would be 2 times 2, which gets us 6 instead of 12. It's just having it. What's important to know is that combinations gives you less ways, unique ways, because instead of having the same thing twice, let's say we had AB, BA would not count. So that means we have less ways. While for permutations, it does count, which is why we would have more ways. For this problem, a bookstore needs to hire 2 people, one as a librarian and the other as a bookkeeper. Alex, Becky, and Christy apply for the jobs. How many possible ways can the bookstore hire people? Well, what we know is that there are 2 jobs, librarian and bookkeeper. So ask yourself, would you care if you were the librarian or the bookkeeper? You probably would, but let's say in this case, yes, you would. So if you were the librarian and let's say you are Alex and the bookkeeper was Becky, if you switched positions, that would be different. So we could say that AB is not the same as BA, which means we would use the one that order does matter, which, if you remember, that's permutations. So this is a permutation problem. So let's use our formula, which is n factorial over n minus r factorial. N would be the total number of, let's say, people, which is 3, and r would be the number of possible outcomes, which is 2. 3 factorial over 3 minus 2 factorial is 3 factorial is 3 times 2 times 1, which is 6. 3 minus 2 factorial is just 1 factorial, which is just 1. So our answer is 6. Thank you for watching. This has been Permutations and Combinations, and this has been provided to you by SATFreePractice.com.